Hello everyone, my name is Keshav Sharma and today my presentation is on Bresenham's line algorithm by Jack Elton Bresenham. This algorithm is a foundational part of computer graphics and its main purpose is to serve as an efficient integer based method for raster graphics, which is in simple terms is the process of drawing lines on a grid of pixel. Moving forward, how do we take a perfect mathematical line and draw it on an imperfect pixel based grid? This is a challenge for few key reasons, like a mathematical line has infinite points, but our computer screen are made up of pixels which are finite. This means we are forced to choose the single best pixel at each step to approximate the true line. Second, the next one is the most obvious method of using the formula like y is equal to mx plus c or b is a bad solution. It requires floating point, which is computationally slow and expensive. Expensive means like taking more memory. Moving forward, uh, this is where Bresenham's solution comes in. It's built in three key advantages, which are first, it's fast. It completely avoids slow multiplication and division and uses fast integer operations like addition and subtraction. Point to be noted is it is integer, not like floating point. Its second is it's accurate. Despite its simplicity, the algorithm is designed to always select the pixel that is mathematically closest to the true line's path, which minimizes the error and makes the line look smooth. Third, it's simple. It's simple. The logic is so straightforward that and efficient that it's easy to implement, and it's even built directly into uh, graphic hardwares like GPUs. The next slide. The core concept. It's all about making one decision at every single step. Uh, um, yeah. So let's start. We just let's imagine like we just plotted our current pixel, which is in yellow, here, and we we're drawing a line with a gentle positive slope. We only have two possible choices for the next pixel. The pixel to the east, which is this, and the pixel to the north, which is this. But the main thing is, how do we choose? We use a special decision parameter which we can call p underscore k, like a point, which is basically an integer value that cleverly tracks the error or how far our plotted pixel is away from the true line. The best part is we just have to check the sign on p underscore k on the decision parameter, whether it is positive or negative. That instantly tells us which of the two pixels we have to choose. So moving forward, let's look the actual algorithm steps specifically for the simple case where the slope is positive and less than 1. It starts with a simple setup, like first we get our input. The line start and end point, which are x0 y0 and x1 y1. Then we calculate our constant, that is delta, by x2 minus x1 and y by y2 minus y1. Then plot our first point. It's the first step. Then the main loop concept. Now we are ready for the main loop, which will run delta x times to draw the rest of the lines. For each step, we perform a simple check, like if uh, p's value, like a decision parameter value, is less than 0, the line is close to the bottom pixel, then we choose the east pixel that was on the previous one. Our next pixel will be like x plus 1 comma y, or x underscore k plus 1 comma y, which is here. And we will update the the p from p underscore k to p underscore bracket of k plus 1. else if its value is 0 or positive, then the line is closer to the top pixel. We choose the northeast pixel and make our next point like x underscore k plus 1 and y underscore k plus 1, and the p point will be updated as p underscore k plus 1. And one more thing, we just repeat this step, we just repeat this simple integer step and check and update every pixel until the line is complete. So, to summarize, Bresenham algorithm is a fundamental algorithm for drawing line in all raster graphics. Its key advantages is the use of integer only arithmetic system, which makes it extremely fast and ideal for hardware. It works by using a decision parameter which is p underscore k to incrementally and accurately choose the closest pixel to the true line at the grid at every step. And finally, while we only looked at one case, the logic can be easily adopted for all 8 octants, which mean it can draw a line in any slope or any direction. Okay. But the main thing is, it is one of the methods to draw a line, but why not the other methods? So, as we discussed, the common method y is equal to mx plus c or b is too slow. It requires a floating point multiplication or division at every single pixel, which is extremely inefficient. There is also a DDA, like digital differential analyzer algorithm. This is an improvement, but it still requires floating point addition for each step. This is slower than Bresenham's pure integer math and can also lead to a cumulative error building up over long lines, like building up a thousand lines, etc. Bresenham's algorithm avoid both of these problems, making it superior, faster, and more accurate. And the last one are the image sources from which the images are used in this presentation. So that concludes my overview for Bresenham's algorithm. Thank you for your time.